Hi everyone, my name's Andy Robertshaw. This is a KenKen that I'm going to solve today. But please forgive me, it's an iPad photo editor that I'm using. It was a scan of a document. It was on the KenKen Puzzles group in Facebook. I've even got to turn the thing to portrait so I can get it all on. Right, but let's. This is quite a hard KenKen puzzle, and somebody was asking for somebody to show how it can be solved. So I'm going to do that now. Just a quick reminder before I go. This is... I normally do killer Sudokus. So some differences between KenKens and killer Sudokus. Firstly, some of the cells on KenKens have operations other than addition. So this is 42 multiply. That means the four numbers there have to multiply together to give 42. I've got an 8 minus there. That means I need two numbers with a difference of 8, either way round. Or a 3 divided by there, it means I need two numbers where one of them is 3 times the other. One divides into the other 3 times. And of course I've got some additions. So we can also have the same number twice in a cage in a KenKen, unlike a killer Sudoku. And also we don't have the sub 3x3 boxes like we do in Sudokus. They're not relevant to KenKen. But this is a 9x9 grid. We can have grids of any size for KenKens. So we have each number between 1 and 9 in each row and in each column. So let's make a start on this. I've got a 5 there, so that's obviously a 5. What I'm going to do now, I'm going to use blue for candidates and red to what I'm working on at the minute. So I'm going to, if I've got a cage which has a definite set of numbers, I'm going to pencil those in blue. So 56 has to be 7 times 8, for example. An 8 minus, and I've got 3 of those. So that takes a full scale. That's a 1 and a 9 in each case. So each of these 8 minus cases has a 1 and a 9. The 17 plus has to be 8 plus 9, the biggest two numbers, to make up 17. I've got a 210 here. That's going to be 5 times 6 times 7. It's the only way I can have 210 out of two numbers. The other interesting one I've got is this 42 cage, which is 1 times 2 times 3 times 7. I need 4 distinct numbers for this because they're all in the same row, and 1 times 2 times 3 times 7 is the only product I've got which gets me to 42. Okay, I'm going to have a look. I'll tell you now, I'm not doing this sight unseen. I have solved it once, so I should know what I'm doing. But let's have a look at this 4,800 cage. It's got 2 factors of 5 in it. It's a number of 100, so it must have 2 5s in the product. Now, the only places I could put 5s, I said I'd use red for what I'm working on now, are one of those two and this one. I can't have a 5 here, here, or here. And I can't have a 5 in both of those. So I must have a 5 in this one. And I must have a 5 in one of those two. I don't yet know which. Let me now have a look at the 90 cage. So obviously a multiple of 5. So I could have, it's 5 times 18. So 5 times 2 times 9, or 5 times 3 times 6. 5 times 2 times 9, or 5 times 3 times 6. But I've got a 2 and a 3 in this 42 cage. So whichever one of 2 and 3 I've got has to occupy this bottom cell. So that's 2 or 3. And on this top row, I've got to have the 5, but with 6 or 9, depending on which of these products I've got. Okay, Let's rub those all out. Let's put those 1, 2, 3, 7 back in. 1, 2, 3, 7. Okay, so what I'd like to do next is have a look at this 22 cage. So 3 numbers that add up to 22. I could have a repeat because I go around the corner in the cage. So I could have 4 plus 9 plus 9. I'll increase the minimum number. So if that's the only one I've got with a minimum 4. I could have 5 plus 8 plus 9. I could have 6 plus, I want another 16. So 6 plus 7 plus 9. 6 plus 8 plus 8. Or 7 plus 7 plus 8. Now remember, if I've got 2 the same, they've got to occupy those 2 corners. But I've already got a 9 in this column, so we can rule out, I can't have 9 in both of those, so we can rule out 4 plus 9 straight away. Could I have 5 plus 8 plus 9? In fact, the answer is no. I'll put something else in now. I'll just go off a slight tangent. I know I've got a 5 there. I've also got a 5 there then. I need another 5 in this 4,800 cage. So I need a 5 there. That means I could not have a 5. I can't have 2 5s. I could have 1 5 just here. But if I got a 5 in this one, then I'd need a 9 in one of those 2, but I've got a 9 in the column already. So we can rule out 5 plus 8 plus 9. We can also rule out 7 plus 7 plus 8, because I'd need a 7 there, and I've got a 7 in this row already. So that's left me with 2 options. What I'd like to do now is rule out the 6 plus 7 plus 9 option. So let's see what... Right, I don't mean to rub that out there. Let's see what happens if we've got 6 plus 7 plus 9 there. Okay, so that would mean a 7 in the bottom row. In fact, it would mean a 9... Let's rub out these scribbles. It would mean a 9 in this one, because I've already got a 9 in this column. It would mean a 7 here and a 6 there. But what effect would that have on the 26 cage? So the most I could have here would be... I've got 5, 7, 9, so 8 and 6 and 4 would be the most I could have there. Which means I would need an 8 or more there, but I've already got an 8 in that column. So I can rule out 6, 7 and 9 from this 22 for that reason. So, once we've ruled this one out, it only leaves 6, 8 and 8. So we know this 22 cage is 6, 8 and 8. And because I've got 2 numbers the same, there's only one way around they can go. So that's an 8, that's an 8. And that's a 6. Right, so what's next then? Let's look at this second row. I'm going to ask a question now. Where could I put a 1 in this row? Obviously not in the first cell. Not there because I've got a 1 in the column. So I'm left with a 1 either in the 26 cage or in the very end one there, in the 3, 2, 4. If I've got a 1 in the 26 cage, then what happens with that? Let's pencil it in. The most I could have is 7 and 9 with it, because I've already got an 8 in the row. 1 plus 7 plus 9 is 17. 17. Right. Sorry, excuse my scribbles. 1 plus 7 plus 9 is 17, which means I need a 9 there, but I've already got a 9 in that column. So I could not have a 1 in the 26 cage, So that means that my 1 must be here in this row. Right. So that's quite interesting now. I've got a 324 cage, which is quite a big product for 4 numbers, and I've got a 1 in there. I need 3 more numbers, which would multiply out to give 324. So I could have 4 times 9 times 9, or 6 times 6 times 9. Right. So what does that mean? Right, I could become a victim of my scribbles. If I've got 2 6s, I need 1 here and 1 here, or else I've got a 9 in both columns. So I could have 6, 6 and 9 there, or I could have a 9 in both columns. So in any case, I have a 9 as one of those. So just hold that thought for a second. So 499 or 669. Remember those. I will rub this out because I want to use the 3 divided cage underneath it. Now, bearing in mind, I've already got a 9 in this 324 cage in that column. No 9 there. So that means there's also no 1. I've got a 1 there. The only 2 numbers which are a factor of 3 apart are 2 and 6. Right, but as they're definite candidates, I'm going to put those in blue. But that means I now have a 6 in this column. So it means I cannot have 669 for my 324. So I did have 6 times 6 times 9, or 4 times 9 times 9, but I can't have that one. I'm left with 4 times 9 times 9 for this 324 cage. And I've got 2 9s in it, so that means my 2 numbers in the opposite rows, opposite columns have to be 9s. And I've got a 4 just there. Okay, so in this right-hand column, I've got 3 and 5 between these bottom 2. So let's put those in. What this also means, I've got a 9 in the top row here, so I can't have a 9 in this 90 product. So that means that my 90 has to be 5, 6, 3. So my 3 goes there, and these 2 are 5 and 6 one way or the other. And I also know what this one is. By elimination, it's 4. The 4 is the only number not in the top row. Okay, so what's next then? So I need a product of 48 for this. 4 times 5 times 5 is 100. So I need to find 48 more to make up the product. Quite a few options for that, so I won't go into that just yet. Now this is interesting. Between rows 6 and 7, I've got a 2 6 there and a 6 7 there. So I have to have a 6 in the 210 cage and the 6 in the 3 divided cage. That means this 84 cage cannot have a 6. 84 is 7 times 12, so it could have been 7 times 2 times 6, or 7 times 3 times 4. But I can't have the 6 in it, so I'm left with 7 times 3 times 4 to go in this 84 cage. 7 times 3 times 4, so let's put those in blue. 7, 3, 4. Do we know which is which? Do we know where any of them are? So it looks like the short answer is no. I'm going to have a look now at this column, this fourth column. I've got 4 plus 5 is 9, 1 plus 9 is 10, that's 19, and another 15 there, that's 34. So the whole column, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, is 45. So this one and this one have to add up to 11. But I've already got a 4 in that column. So my only way to have 11 between this and this is to have the 3 there and an 8 there. So let's get those in. So this one is an 8, and this one is a 3. These two are 4 and 7 between them. That 15 cage at the bottom is therefore 2 plus 6 plus 7. So what have I got? This 4,800 cage, 4 times 5 times 5 times, so 3 5s and an 8. Only 2 5s and an 8. I was a bit worried then. I've got 800. I need another 6 to multiply between this one and this one. I can't have a 1. I've got a 1 here and a 1 here. So I can't have a 1 in either of these two cages. So that's going to be 2 times 3 to make up the 6 one way or the other. I can't immediately see. I can see which way round. I've got a 3 in this second row. So I know I must have a 2 here and a 3 here. In column 3 now, I've only got a 2 left to go in that one, in row 5. In this 26 cage, I've got 4, 7, 9 still to go in. 4 plus 7 plus 9 is 20, so I must have a 6 then to make up the 26 there. In fact, the only place I could have a 9 is in the middle of this one. So that one's a 9. These two are 4 and 7, one way or the other. I don't know which. I'm sure we'll find out soon enough. Okay, what else have I got? I'm going to use a deadly pattern now. So this is a common technique for Sudokus. I've got 5 and 6 there. So I must have, in this 210, my 5 and my 6 must be in opposite columns. If I had a 7 there, I'd have 5 and 6 between row 7, column 1, row 7, column 2. I could swap this 5 and 6 round and this 5 and 6 round and have 2 solutions. The KenKen shouldn't have 2 solutions. So the only way to do this is to have 5, to avoid the 2 solutions, to have 5 and 6 on opposite rows. So in fact, what I must have then, let's rub that out. I must have a 7 in this one and 5 and 6 one way or the other there. So let's rub that red ring out. So that was an 8. Those two were 5 and 6 between them. And now in this 84 cage, I've got 7 on the top, 4 on the bottom. Okay, so what is next? I've got a 7 difference here, but I've already got 8 and 9 in the top row, so I could have 1 8 or 2 9. I don't know which pair I've got, but I do know my small number is on the top, my large number is on the bottom. So 7 and 8 in that fourth row are between this one and, in fact, ignore I'll take that back. It's 1, 8 or 2, 9. So this one is 8 or 9. Right, so what I was about to say was invalid. On row 3, I've got 1, 2 and 7 left to go in, but I've got a 7 here. So the only place I could possibly have a 7 in row 3 is this one. So anything else jumping out? I've not looked at my 168 cage at the bottom. 7 times 24 is 168. So 746 or 738. And either of those still look possible. So I won't do anything there yet. My 13 cage here, I've got a 9 in the column and I've got 7 in each row. So it can't be 9 plus 4, it can't be 7 plus 6. It only leaves 5 plus 8 for this 13. Now that's interesting. My 4 divide here is have to be 1, 4 or 2, 8, but I've got an 8 in the column. So I can't have 2 and 8, so that's going to be 1 and 4. Now I know which way around these go. I've got a 4 in this column, so that's going to be a 7, and that one is a 4. Right, so right. Can we see anything else? I'm sure we can. So there's a bleeping noise in the background. Forgive me if you can hear that. Right. So looking at the 168 again, I've got a 4 and 6 in this column. I should scribble in red. So if it's 7, 4, 6, the 4 and 6 would have to be those two. But it could still be 7 with 3 and 8. In fact, this is interesting. This 3 difference. Cannot use a 5 or a 6. I've got a 5 and a 6 between those two in this column. So it could be 1, 4, not 2, 5, not 3, 6. Could be 4, 7, not 5, 8, not 6, 9. So 1, 4 or 4, 7. So 1, 4, 7. I certainly do have a 4 there. I'm not sure how interesting that's going to be. So let's. In fact, with 5s and 6s both in these in these left-hand columns, I can't have a 5 or a 6 in the 13. So that only leaves 4 and 9 for this 13. So that 13 is 4 plus 9. Which means that of this 1 and 9, the 9's got to go on the top, the 1's got to go on the bottom. So I've got my 1 in the bottom row. And this 15 has 3 and 5 there. So 3 plus 5 is 8. I need 7 to go with that without using the 1. So I could have 3, 4 or 2, 5 there. Yeah, so it could be either of those. So can we see anything else? So let's look at some individual cells. This one's going to be 1 or 2. That's a 16 cage. I've either got 1 and 2 or 2 and 2 in it. So I need 12 or 13 between these others. If it's 12, it will be 3, 9. If it's 13, it'll be 4, 9. So let's put 3, 4 and 9 in there. The important thing is that I've got a 9 there. In fact, I need a 9 here, so I can't have a 9 in the bottom row of that column. So in this 13 cage, the 9's got to go on the left-hand side and the 4 on the right-hand side, which eliminates the possibility of the 4 there. So it only gives me 3 and 9 between those two. That's 12. So to make up my 16, I need a 2 in this one and a 1 there in the 7 difference. And of course an 8 to go with the 1. This helps with that 56 cage, 7 on the top, 8 on the bottom. Right, so what have we still got? I've got a 3 difference. I've used the 1 in this column now. So that's going to be 4 and 7, but I already have a 7 just here. So the 7's got to be on the top of that one and a 4 underneath it. And I've only got one value left for the remaining entry in this column, which is a 2. So this one is a 2. I could have a 1 or a 4 here, but I've got a 4 in the column. So that is in fact a 1. So does that help? I've got a couple of places I could have a 1 in this row, in row 7. So I can't fill that in yet. Right, I've got a 9 in column 7. I've got all my 9 candidates in at least, without knowing which one goes where. In fact, yeah, this 17, I know the 9 on the top, the 8 on the bottom. So this 8 difference, the 9 on the top, the 1 on the bottom. So what have I still got? This 168, 7 times 24, I don't know where the 7 is yet. And I don't know if it's 746 or 738. Right, still got several options for that one. So what else can we see? So of the number 9, I've only got two more to go in, which are those 2 between them. 1 pairs with a 1, 1 pairs with a 3. So let's have a look at this column 8. I've got 1, 4, 5, 7, 8, 9. So 2, 3 and 6 between the remaining squares. So 2 or 3 to go in the top row. 3 or 6 for that one. Again, I'm not really seeing anything. What I am seeing in this one, I've got a 6. Already got a 6 spoken for in row 7, because row rows 6 and 7 have a 6 in the 210 cage, a 6 in the 3 division cage. So the top one isn't a 6, it's also not a 7 because I've got a 7 there. So that top one of this 15 sum is a 2. 6 and 7 one way or the other in the bottom 2 rows. So what have I still got to go in the second bottom row? 6, 7, 3, 5, 4. What could I have? Oh wow, I've got an 8 difference here, so I should have had a 1 in there. What can I have here then? So I can't have 5 or 6 because I just explained the 6 in both rows. I've also got a 5 in both rows between the 210 and the 13 cage. So it only leaves 3 or 8. In fact, let's not make it so complicated. I know which way around this one goes now. So 2 and 6 that way round. I know which way they go. So the 5 there, the 6 there, and I know which way they go, 6 before 5 on that one. I also know which way round this 5 and 8 go in the 13 sum. And it leaves me the 3 in that one there. Total of 10 between those two. Not 1, 9, not 2, 8. It could be 4, 6 or 3, 7. It's not 3, 7 because I've got a 7 in both columns. So it is going to be 4 and 6 there, but I've got a 4 in that column. So it'll be 4 on the left-hand side and 6 on the right-hand side. So I can do those now. 7, 6 like that. So I can't have a 5 in the 168, obviously, because 5 isn't a factor of 168. So 3 there and 5 there. So 7 and 8 between those two. But I've got an 8 in one of the columns already. So 8, 7. So what have we got here? 2, 3, 5. I've got 2 and 5. In fact, 3 is the last number to go in that column, isn't it, anyway? So let's put the 3 in that one. The 3 there like that. And 2 and 5, I've got a 5 in column 8. So the 5's got to go on the left-hand side, the 2 there. I could probably do something with this now. 1, 2, 3, 7. I've got to have a 3 in the rightmost cell. 1, 2, 7, got to have a 7 in the leftmost cell. It leaves me 1 and 2 for the other two. But so I've got a sum of 23 there, plus 3 plus 4 plus 5, that's another 12. That's 35, and 9, 44. Remember, they all up to 45, so I need 1 on the right-hand side to make that up to 45, and 2 on the left. So the set of missing numbers are 2, 8, and 9 for this 23 cage. But the 8 on the bottom, the 2 has to go there, and the 9 in this one. So what could I have here then? I couldn't have 1, 2, 2, 4, 4, 8. It only leaves 3 and 6, where 1's twice the other, and the 6 has to go on the left. So 6 and 3 like that. So I know which way round, the 9 on the top, the 3 on the bottom. And on this one, the 1 on the top, the 9 on the bottom. And on this one, the 4 on the top, the 1 on the bottom. So I've got to have a 1 in there, and 5 and 4 in these last two cells, 4 on the left, 5 on the right. Okay, well, I hope that was helpful. There's the solution to the puzzle. Once again, please excuse my terrible handwriting. Yeah, but thank you for watching. See you on the next one.